Hi there, I'm Mike from Prep 101, and in this primer, we'll be going over balancing reactions. This is often the first step in longer questions and is sometimes even asked about in multiple choice settings. Without any further ado, let's get right into it. We'll start out with some relatively easy examples and try to use those examples to harness your intuition for some of the more difficult ones. Let's start out by considering the construction of a unicycle. We're asked to fill in the following reaction to ensure the ratio of parts to products is correct. Well, we probably know that it takes one wheel and one frame to make one unicycle. In a chemistry setting, we're even more likely to have the product broken down for us in terms of the reactants. For example, instead of a unicycle, we'd be seeing something like a wheel frame. Here, when we see these blanks, the blanks means that there is only one of those things. We have one wheel on the left, one frame on the left, and on the right, we have one wheel and one frame bonded together. Let's take a look at a more difficult example now, with a bicycle. We're asked to fill in the following reaction to ensure the ratio of parts to products is correct. And like last time, even though bicycle is there to help us train our intuition, in a chemistry setting, it would instead be written as something like wheel to frame. Now, intuitively, you probably know that it takes two wheels, one frame, to make one bicycle. But let's do this in a more chemistry-style way before we move on to something a little bit harder. We can look at the numbers that are present in this reaction. We see a 2 in the wheel to frame. What that means is on the right side, we have a total of 2 wheels. As written, on the left side, we only have one wheel, because remember, if there's nothing written there, it's considered to be a 1. Now, since we have 2 wheels on the right, we're going to need 2 wheels on the left. We can check this with our frame as well. There is nothing written as a subscript on the frame on the product side, which means it's just a 1. And similarly, that means there's going to be a 1 on the reactant side. There's one thing that I want to highlight before we proceed here, and that's the difference between 2 wheel and wheel 2. 2 wheel means that there are 2 discrete, separate wheels. So these wheels aren't bonded together in any way, they're just 2 wheels that are maybe in the garage or whatever like that. On the flip side, wheel 2, in this context, means that there are 2 wheels that are bonded together. And they're bonded together through the frame. We know that based on how a bicycle works. But when you see a subscript like that, that's telling you that those 2 things are bonded. The next example comes from one of those age-old problems. Hot dog wieners come in packages of 10. Hot dog buns come in packages of 8. We're asked how many of each package are needed to make one hot dog. Okay. So we can write down our reaction here. We have wieners plus buns going to a hot dog. Try doing this question by pausing the video and giving it a go. All right, fantastic. The first thing to notice is that if you have a package of wieners, a package of 10, then all of those things are bonded together. All of those 10 wieners are in the same package. Similarly, if you have a package of 8 buns, all of those buns are bonded together. Now, it might be intuitive, and depending on where you went to high school, you might say, oh, well, let's see, I need to find the lowest common number here. Maybe that's a little hard. Maybe I'll just try multiplying both of these things together. and I'm saying I would need 8 packages of wieners and 10 packages of buns, giving me 80 hot dogs. Looking at that though, I think it's pretty clear that you can reduce this a little bit. So instead of having 8, 10, and 80, we can divide each of those by 2 and get 4, 5, and 40 hot dogs. We have a total of 40 buns and a total of 40 wieners, giving us a total of 40 hot dogs. Depending on where you went to high school, you might have stopped there. For a lot of university questions, you're going to need to take this one step further, or maybe consider it in a different way. This question is very specifically asking how many of each package are needed to make one hot dog. In other words, we need to end with a single hot dog. Right now, we have 40 of them. So there are 2 different ways you can go about this. I'll show you my favorite. I can say, I know that I need to have 1 hot dog. I can't change the sizes of the packages that these things come in. But if I need 1 hot dog, that means I need 1 bun. If there are 8 buns in 1 package, then I'm going to need 1/8 of a package. Similarly, if there are 10 wieners in 1 package, I'm going to need 1/10 of a package. The other way to do this type of question would have been to solve in this way first, and then divide each of these numbers by 40. But I think skipping straight to the answer is a little bit more straightforward, both conceptually and mathematically. Finally, we have a wonderful ending example. This tells us that butane, which is C4H10, combusts in the presence of O2 to form CO2 and water, H2O. What is the reaction that represents 1 mole of butane combusting? This is absolutely something that you're going to see on one of your midterms or exams. So take a moment, pause the video, and give it a go. All right. I'm going to start out with my unbalanced equation. I'm told in the question that I have butane, C4H10, and oxygen, O2, as my reactants. My products are CO2 and H2O. All right, so now the trick here is to figure out what is going to be relatively easy to balance. I'll give you an example of something that isn't easy to balance first. The oxygens are in 3 different places, so that's going to be a little bit tricky. Instead, let's balance things that are only in 2 places. They'll be a bit simpler. I'm going to start out with the carbons. I have 4 carbons on the left, and the question tells me I need to have 1 mole of butane combusting, which means I'm locking in a 1 on that butane. That tells me that I'm definitely going to have 4 carbons on the reactant side. What that means is that I'm going to need 4 carbons on the product side, so I can lock in a 4 on that CO2. Second, let's do a similar thing with the hydrogens. I know I'm going to have 10 hydrogens based on the amount of hydrogen in butane. Over here on the water, I need a total of 10 hydrogens, but there are 2 hydrogens per water, so I'm going to have 5 water molecules. This last step is the trickiest. I want to find the total number of oxygens on the product side. I have 8 oxygens based on the carbon dioxide. I multiply the number of molecules times the number of oxygens per molecule. So 4 times 2 is 8. And then I do the same with water. Here it would be 5 times 1. So the total amount of oxygen atoms on the right side is 13, which means I need 13 on the reactant side. Now don't fear fractions here. The best way to do this is just to write 13 over 2. If you were to multiply this entire reaction, like would be tempting based on how it's taught in high school a lot of the time, if you were to multiply this reaction, then we would no longer be solving for the 1 mole of butane, and we would actually be answering the wrong question. All right, let's summarize this. Your key points are to ensure that there are equal amounts of each atom on both sides of the reaction arrow. Second and finally, don't fear fractions. Fractions are going to actually make your life much easier, and you won't fall into the common pitfalls of balancing. I hope you found this video helpful. If so, check out others like it, outlining the foundations of first-year chemistry in this Primers playlist. Also, be sure to join the Facebook Study Hub group. I'll put a link in the description so you can find it easily. And finally, I hope to see you at our preparation sessions. This is where I'll be outlining how to do so many questions so you can go into your midterm and exam with confidence and earn top marks. Many of the midterm preparation sessions are actually free. That's right, free. Go to prep101.com for more details. Thank you for watching.